So we've been talking in this chapter about polynomials. We did graphing quadratics, graphing polynomials and their characteristics, but we're going to stop on that for just a few minutes or for this section and talk about specifically dividing polynomials as well as some theorems that apply to that before we move to the next section. We're going to begin this lecture by talking about long division. Now, most students hate long division. You stopped liking it when you had to do digit division, digit long division back in, like, I don't know, the 4th grade. And that's what we're going to look at for just a second, though, because it kind of helps us understand where we're going when we do it with variables or polynomials. So, way back when you did 772 divided by 15, the process you went through was something like this. Well, you'd ask yourself, what do I multiply 15 by to get it close to 77? And that happens to be 5. 5 times 15, so when we've kind of come up with a number, we take the number on the top, multiply it by this one that's on the outside, so 5 times 15 is 75. Then you subtract it. Now I know you do this so quick in your head you forgot that's what you do, but you subtract. When I subtract, I get a 2, and then I bring down the next place, the next 2, and you start all over again. 15 times what is 22? Well, 1 is the closest I can get. 1 times 15 is 15. Subtract, and I'm left with 7. Now, I don't have anything else out here. I don't have any decimals, so we're going to write this as the remainder. Remember, the remainder, this is 7. 7 is the remainder, and I'm going to write that as a fraction, 7 over 15. This is how we did long division a long time ago, and it's the same process we're going to use in order to talk about this next example. Okay, so we're going to apply that principle, only this time I'm going to use long division to divide this polynomial by this binomial. So this long polynomial is what goes under the house, we could say, and it looks like, it looks like 6x cubed plus 17x squared plus 27x plus 20, and I've got 3x plus 4, so it's this divided by this, so the 3x plus 4 goes on the outside. When I'm dividing, so this is what I'm thinking of. Okay, so when you're looking at this, you're going to start with this leftmost term, 3x, and you say, well, what do I multiply 3x by to turn it into 6x cubed? Hopefully you're saying that that's going to be a 2x squared, because 2 times 3 is 6, and x squared times x is x cubed. Now when we do polynomial long division, though, I'm going to surround this binomial with parentheses so that I can remember that this number on the top has to be multiplied into not only the first term but the second term, so it's like the distributive property. So we take 2x squared times 3x, and we get 6x cubed. Then 2x squared times 4 is a plus 8x squared. I'm going to get rid of these arrows for a second. And what did we do above? We have to subtract. Now when you're subtracting your polynomials, though, make sure that you not only subtract the first one, but you subtract the second one. Or in other words, I'm going to change the sign for both of these terms. Then this one should cancel, and we just subtract here. So 17x squared minus 8x squared gives me 9x squared, and we bring our plus 27x down, and we start all over again. So you ask yourself, well, what do I multiply 3x by to turn it into 9x squared? That should be 3x. So 3x times 3x is 9x squared, and 3x times 4 is 12x. But don't forget to change your signs. Oops. Now my 9x squared cancels out, and I have 27x minus 12, which gives me 15x, and we bring down plus 20. So what do I multiply 3x by to get 15x? And that should be just a 5. 5 times 3x is 15x. 5 times 4 is 20. But I've got to come through and change this sign and change the second sign. When I subtract, I end up with 0. What did that mean for us with long division originally? It meant that I have no remainder. In other words, this is the solution right here. Okay, so a little terminology. This right here is the quotient. So the quotient. And this value down here, I don't have anything left, right? I have no more values to bring down and keep on dividing. So this is, although it's a 0, it would be where my remainder was, if I had a remainder. Okay, and that's how you're going to do long division.